Now the D expression for deviation will be sine inverse of mu sine R1 plus okay, so some of you are getting confusion. I will start with sine I1 equal to mu sine R1, mu sine R2 is equal to sine I2. Solving this, we got expression for I2 as yeah, this particular thing. Let me use this part. Let me substitute all these things. Deviation is equal to I1, I can write it as sine R1 Okay, let me differentiate this with respect to R1 because I have to calculate the minima. Differentiating about deviation with respect to R1. Differentiating respect to R1. So d R1 is equal to sine inverse of this will be sine square R1 minus mu sine inverse of x. This will be x root of 1 minus of mu cos of a minus R1 by root of mu square sine square a minus R1. How we got it? First, I'll differentiate sine inverse. Sine inverse, everything this will be x. So what we write dx by root of 1 minus x square. Then again, derivative of sine R1 will be cos R1. Okay, for this for minima, what is needed? The first order derivative should be 0. For minimum, this should be equal to 0. So this will be 0 only when a minus R1 this is possible only when cos R1 and cos R2 are should be positive, no? Or we should better say like this is possible only when these two square roots are positive. So above condition is possible only when roots are positive. So therefore, for the roots to be positive, what are the only when square roots are positive. So therefore, what is the basic necessary condition? R1 should be equal to A minus R1 or 2R1 equal to A or R1 equal to A by 2. We know that R1 plus R2 equal to A. So substitute R1 equal to A by 2. So R2 is equal to A by 2 negated. So what is the condition for minimum deviation? R1 equal to R2 equal to A by 2. Similarly, I1 equal to I2. We know minimum deviation. I1 equal to I2. I1 plus I2 minus A. So therefore this will be I1 plus I1 minus A. So minimum deviation equal to 2I1 minus A. What is I1 equal to? Delta minimum plus A by 2. R1 equal to, already we written A by 2. So let me take help of these two ideas. Let me apply the Snell's law. We know that sine I1 is equal to mu sine R1. Let me substitute the value of I1. Sine of delta minimum A by 2 equal to mu sine A by 2. So what is the mu of prism? Sine of delta minimum A by 2 by. This is something very important. Like a, can I measure delta minimum in a lab? That's very easy. You can, with your eyes, you can able to measure that minimum deviation. When you keep the prism on the prism table and as you rotate, hmm, so you can clearly see that the ray will get minimum deviation. And you are able to measure delta minimum. You know angle of prism. You will get the mu, the refractive index of the material. There's a main idea of the prisms, like why do we use minimum deviation? To just predict the refractive index of the material of the prism. That's the main purpose of this mu. Getting the idea? This one? So what we can write here? We can easily measure in a lab. So as you can measure easily delta minimum and the angle of prism. So the mu of metal of prism, what happened? We can calculate using this particular formula. So the what is the major application of this particular formula is like a, you can measure the with the minimum deviation you can measure the material of the prism, that one. So what is actually what happens in the minimum deviation? Next idea. A few questions like what actually happens at minimum deviation. So we'll take the prism. So we are not understanding what is actually that minimum deviation. If this is the prism, if this is the ray incident, the ray wanted to traverse straight here. This is the minimum deviation. One more. This is what that minimum deviation. This is the incident ray. Refracted ray. This one. So how the refracted ray will be parallel to the base of the prism. This is the base of the prism. At minimum deviation, this is what happens. And out these two are, they will be parallel. The refracted ray inside the prism will be parallel to the base of the prism. So at minimum deviation, the refracted ray will be parallel to the base of the prism, and these two angles will be equal. Let me write only I. Don't have in this. I'll draw another one. Yes, yeah, now this will be the, okay, I think, yeah, this was our diagram. Fine. So this will be the, and these two will be symmetrical. The incident ray and the emergent ray will be again symmetric. This will be symmetry. The emergent ray will be symmetric to the incident ray. The ray wanted to traverse this our minimum deviation. The ray wanted to propagate along this green color dotted line. Due to prism, it will undergo the deviation, and the deviation will be minimum. At minimum deviation, the refracted inside the prism will be parallel to the base of the prism. This is one very basic idea. So these are very important. At minimum deviation, the refracted will be parallel to base of the prism. I think I'll conclude this thing. Incident angle is equal to emergent angle, where E is nothing but I2 only. I just change its symbol, and these two angles will be equal again. R1 equal to R2. So what is the main purpose of minimum deviation? Why we use in the lab? To find out the refractiveness of material of the prism. So like this, we will